Hello everyone, today we'll be discussing problem number 140 from the book Irodov. Let's begin. It says that a small bar A resting on a smooth horizontal plane is attached by threads to a point P and by means of a weightless pulley to a weight B possessing the same mass as the bar itself. Besides, the bar is also attached to a point O by means of a light non-deformed spring of length L naught equal to 50 centimeters and stiffness x equal to 5 mg by L naught, where m is the mass of the bar. The thread PA having been burnt, the bar starts moving. Find its velocity at the moment when it is breaking off the plane. Okay, so let's understand the situation. As given in the question, we have to find the velocity of bar A when it is breaking off the plane. Let's say it's going to break off the plane with the velocity v. Okay. So now let's assume this extended length of the spring is L dash. Okay. Let's do it neatly. This is L dash. And the angle over here is theta. Right? And this length is given as L naught. Now to get to this point of the plane, A will have traveled some distance y. Right? So this distance y can be written as L dash sine theta. Right? Right? L dash sine theta. Now we know that L dash cos theta equals to L naught, and hence L dash equal to L naught by cos theta. Now if we substitute this value over here, we get y equals to L naught tan theta. Right? Now if A has traveled this distance, which is y, B will also have traveled the same distance but vertically. B, right? So now let's simply apply a total mechanical energy conservation. So applying TMEC, total mechanical energy conservation, we get initial kinetic energy plus initial potential energy equals to final kinetic energy plus final potential energy. Right. So from the situation we understand that initial kinetic energy and initial potential energy is zero. And because A and B have traveled the same distance, which is y, they both will end up with the same velocity, right? Hence, of the system, the final kinetic energy is half mv square for A, bar A, and half mv square for block B, and potential energy of spring plus potential energy due to gravity, right? And this is zero. So 0 equals to half mv square plus half mv square. We can write it as mv square plus potential energy of spring, which is positive half kx squared, right? And potential energy due to gravity. This potential energy will be in negatives because B has come down from this reference point where we assume u to be 0. B has come down, so potential energy will decrease. So its potential energy will be minus mg y. Now we get mv squared plus half kx square equals mgy. And we know that k equals to 5 mg upon L naught, because this was given in the question over here. K is nothing but x. We assume K to be the stiffness. This is 5 mg by L naught. Now let's substitute the values. Square plus half into 5 mg upon L naught into x square. So here x is the extension in the spring, right? Extension. So we can calculate x like this. So x is basically L dash minus L naught, and we know that L dash equal to L naught by cos theta. So x is equals to L naught upon cos theta minus L naught, which is equals to L naught into 1 by cos theta minus 1. So let's substitute that value over here. This is equal to mgy. So mv square plus half into 5 mg upon L naught into L naught square into 1 minus cos theta upon cos theta whole square equals to mgy. Now let's cancel out all the m's over here. Right. Now we must also note that when a is over here, let's draw the situation once. This is the pulley. Okay. A will be here, and somehow like this is some spring force FSP. This is the initial position of A. This angle is theta. Now if you draw the FBD, we get this is F spring, which is equals to K into X, where X is the extension. This is mg, and if we draw a line like this angle is theta. So now if we balance, what we get is that we get kx cos theta equals mg, because if we observe here, this is mg, this is mg, and this is kx. This angle is theta. So taking the components like this, we get kx cos theta equals mg, right? And we know the values of k and x, so let's basically substitute. We get 5 mg upon L naught into L naught into 1 by cos theta minus 1 into cos theta equals mg, right? Right. Now let's cancel out mg. L naught 5 into 1 minus cos theta by cos theta into cos theta. So this should also get cancelled, right? Now we get cos theta equals to 4 upon 5 from this. So this is an important result. Now, if we look at this equation, what do we get? We get, let's write over here, v square plus 5 L naught by 2, 5 L naught by 2 into 1 minus cos theta upon cos theta whole square equals gy. Right. Now we know the value of y. Y is supposed to be L naught tan theta. Let's substitute it over here. Okay, let's take another page. Let's fit it over here. V square plus 5 L naught upon 2 into, let's substitute the value of cos theta also. Here we get 1 minus 4 upon 5 by 4 upon 5. Right? The whole square equals to G into L naught tan theta. So now if you carefully observe, let's draw a triangle with theta over here. Cos theta is adjacent upon hypotenuse. So this will be 4, this will be 5, and this is 3. So tan theta will be 3 upon 4. Let's substitute it. V square plus 5 L naught by 2 into, this will be 1 by 4 whole square, which is 1 by 16, right, equals G into L naught into tan theta, which is 3 upon 4. Okay. So it will be 3 upon 4. Now V square equals 3G L naught by 4 minus 5 L naught by 32, right? Now V square is equals to 24G L naught minus, there should be one second. Yeah, I think there should be a G over here, right? And is that? Yeah, there should be a G. Not G, right? Minus 5 L naught G upon 32. Hence V square equals to 19G L naught upon 32 is equals to, then V is equals to 19G L naught by 32. Right? This is our answer. But if you wanted to expand it a bit more, what we would get is, and it was given in the question that L naught is equals to 50 centimeters, right? Which is half meter, right? So L naught is equals to 1 by 2 meter. If we substitute that in there, we get V is equals to root over 19G by 64, which is equals to root over, sorry, which is equals to root 19G upon 8. Either of the answers are correct. So this was the solution to problem 140 of Irodov. So if you like it, please subscribe to my channel. And that's it for today. Thank you.